go ahead and get started. It's not really an administrative note, but something I mentioned on Tuesday was, right, this week we're starting on the final project part of the class in the lab experience, and a couple extra thoughts about that. As I had already mentioned a couple times, previously, it is different in the sense that it's having you do very similar things, but it's not telling you each step that is needed along the way. And those of you who've looked at it already, I know the Friday lab, we'll look at it tomorrow. You're already sort of seeing that it's different in the sense of it's not just jump in, command, 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 jump on out. You have to think about what you want to do, and you have to go back to prior ideas. And obviously that's more difficult. That's a more challenging lab than the prior ones. A couple thoughts about that. First, I have sort of, told the TAs their job really isn't to walk you through this one in the way they may have helped you debug some command line or other thing that was happening in the prior labs. That's not to say they shouldn't be helpful. They're not supposed to be dismissive or say, you figure it out. But it may feel that way to you a little bit. If they were to tell you what the next step was, that would really defeat the purpose of this particular lab, these last few weeks that we have together. So it's going to be a different kind of experience. Similarly, although I do love collaboration, I love students helping students, specifically for this, I really want this to be a testament to your own individual work. We're not going to be, looking over your shoulder and confirming that you didn't share a particular command line flag with somebody else. But I really do want it to be individual effort. It's not one group submission for the entire class in whole or in part. We're not going to police that very carefully, but that is the intention behind the assignment. So it's going to be a more difficult assignment. On the flip side, if you look at our calendar, I don't have Canvas open right now, but if you go back and look at our calendar, it was intended to be a 2-week assignment for this part and 2 weeks for the second part. Because of how our Thanksgiving break kind of lines up with that, it is effectively, this first part, a 3-week assignment. So that is most certainly more than enough time to complete this assignment. But for some of you, and it depends on how thoroughly you've been taking notes earlier in the semester, how much you were maybe just following instructions versus digesting instructions prior in the semester, you may have to kind of go back and kind of look at prior labs and really sort of study what did we actually do in lab 2 and then lab 3 and then lab 4. How did that relate to what we talked about in lecture, and what other things should we really be considering for this? If you don't do that, you'll have no idea where to really get started. And so if you were to ask the TA, I have no idea how to access this machine, this particular computer, this IP address that's supposedly available, the answer from the TA should be, look back to lab number 3 and what we did for that lab. And it doesn't tell you exactly how to do it, but digesting that information should lead to a path forward for how to do those steps. It's not meant to be a hair-pulling experience, but it's okay given the timeline we have. It's okay to be a little frustrated at times with this lab experience that you don't know what to do next. Sometimes you take a break, other times you review notes, look back to what you'd previously done, and there's nothing brand new in terms of what you have to do for this new lab. That's my spiel on the lab. Other than good luck, I think you're going to be, we're all going to be okay. Where we left off on Tuesday was kind of a weird side quest that I enjoyed way too much. I kind of wanted to continue it. We were talking about auditing and remediation, and auditing, at least in part, is a task of sort of log consumption, right? Looking at the various and potentially quite a bit of data that gets generated by all the software, all the services, all the tools you have running in your infrastructure, and finding an automated or semi-automated way of, determining actionable information from that. This example is a little silly, but it was kind of our starting point to kick off our side quest, which was, if we're looking at authorization logs, something one can do is look for a basic string of invalid user. And then with the grep command, you look for that string. You can also specify, print out 3 lines before that line and 1 line after a line in which invalid user shows up. That is a very quick and dirty kind of auditing log that you could determine when there was some potential attempts. You could then, and what we can maybe play around with a little bit today, do other things with that. What we did on Tuesday was, well, this is kind of an obvious string. What if there was some more custom application-specific string we really cared about? We kind of dove into regular expressions on Tuesday and just were playing around with them. That's not necessarily a learning outcome of this class. And so if you didn't get that topic, review that topic in the video, or in your free time over break, look at regular expressions. It's a good life skill, certainly. But that second part of, we maybe can determine what particular regular expression is interesting to us to figure out what matches are relevant. Now, what do we do with that information? Just printing it all out is possibly a valid step. That's all the grep command is doing here. But when you have that command line interface, Windows or Linux, Mac OS, it doesn't really matter. You have a lot of power at your fingertips that you may or may not be realizing. And while there are courses that will teach you just how to become kind of expert in command line, has anyone here taken ComSci 2520 or 252 already? Just a couple of you. I think it's, even if you've taken the class, it's sort of a lifelong kind of thing to get better at that kind of skill set. Oftentimes, you don't really get better at it until you realize you have to for some particular purpose. That's true of a lot of skills, obviously, but it's such a way to level up your ability to just interface with computers, to kind of automate things that could take somebody else hours, days, weeks, what have you. You realize that with the power of not just programming, which you already have some developing skill with, but just using the command line in a more expert way really just makes you a more capable engineer, more capable cybersecurity professional. So I thought we'll give it no more than 10 minutes today. We can't spend a whole week on these kind of side things. Let's play around with a similar utility to the one we did on Tuesday. That was for regular expressions. This one would be for command line and just basic command line stuff. I know 230, 2300, as well as this class, have you used the command line. But it is definitely one thing to look at a command and type in a command, or look at a command and copy paste a command. What is missing, and what you only will get if you are just sort of personally driven or curious about it, is the understanding of what exactly these commands are doing. And what's definitely missing is how we can potentially compose these commands together to do something that is otherwise possible with a few hundred lines of Java code, but can be done just in one line with our command line interface. So the utility I found was, there's a bunch of them. This is a more popular thing than looking at regular expressions. I don't know if I can increase the font. I'll give it a try. This is called the command challenge. We cannot do all of them. We can start. And it presents you with sort of a virtual terminal here and says it's meant to be like a bash-like terminal. And can you get the terminal to do the things it's asking you to do? There's always a little bit of a chicken and egg thing when dealing with bash scripting and dealing with the terminal, is that, as I've mentioned, there are all these very powerful utilities that have been built over generations now to do lots of really good sort of text and data processing things for you. There's also a full scripting / programming language through bash that you can also just use. But even short of that, just the utilities themselves are very powerful. But the reason I say there's a chicken and egg issue with it is that there's all these really cool utilities, but if you don't know the name of the utility, you don't really know where to start. So part of the issue is perhaps a Google search, perhaps just knowledge from experience of how do I do this with a command line, and you'll learn, well, it turns out for many of these cases, there's either a command argument or a utility that does exactly what you need to do, or if it doesn't do exactly what you need it to do, it has a couple flags and optional arguments you can pass to it that then does exactly what you need to do. Or if not exactly then what you need to do, you can take the results of that argument, connect it to the input of another command, and connect that to the input of another command, and chain these things together to do pretty powerful things. But we start with the very basic one. This would be printf if it was C, or console.print if it was Java. What is the equivalent of that? Of course, you can do printf, but what is the equivalent of that in bash if I just want to display hello world? Do we know what that command is called? It's called echo. The honest answer for why are any of these commands called any of these things is historical reasons. One of the historical reasons is there was a time when we were either locally connecting to the VT100 terminals or even remotely connecting over very early days of the internet, where each keystroke was an investment. Not that huge of an investment, but there'd be an actual latency associated with typing these things in. So you will see that these commands all err on the side of brevity. They're not meant to be expressive. If we were doing this in PowerShell instead, invented in the more modern era, it'd be much more like clear what the commands were. They'd be longer, more lengthy. It'd be almost like writing a sentence. This is a little bit more old school, still very much in use. The command just happens to be called echo. If you say, I didn't know the command was called echo, all I can tell you is, now you know. I mean, you've just gained knowledge that you didn't have. Echo allows us to echo out some combination of just hard-coded strings, variable encoded strings, to do something else with potentially next. In that case, it was just printing it out. There's still value in that. If you're running a script and you want to print out certain things when they're happening, you would use the command echo for that. So this is kind of a quiz of what you already know, or just an exploration of things that you are yet to know. And the truth is, like a lot of programming things, people are very opinionated about the exact perfect right way to do certain things. For some of these, there'll be probably lots of potential solution, maybe dozens, maybe even more. I don't really ascribe to that for this kind of thing. If it works, and you can understand why it works, it's good. It's sufficient for your purposes. There is a utility that prints the current working directory. We'll start with quiz mode. Does anyone happen to know what printing working directory, what that command is? It's PWD. Again, why didn't they call it print working directory in all caps or something? It's because at the time it was invented, 3 keystrokes was considered sufficient for that. That will print out the working directory. All right? What command lists all the files in a directory? ls. Some of these, the acronym is obvious. Others, it's not. Some are even people's own initials, and it has nothing to do with the purpose of the command. But ls should, in fact, give you that information, and we're succeeding. We're leveling up already. There's a file named access.log in the current directory. Print the contents. There's a lot of ways to do this. What is the standard way to print a file's contents in Bash? Cat. Someone can tell me why it's called cat. I don't think it stands for catalog, but let's just assume it stands for catalog. Cat access.log. Okay, those are the first just getting started things. The truth is, this is just a set of exercises, but these are the kind of things when you want to process a log file, you want to print the contents of the directory, you want to search for certain things, you want to extract only the most useful information out. So these are synthetic examples, but they're not that far from what you would be doing. You can take what you would learn in this process, and again, we'll maybe spend like 3 or 4 more minutes on this, and apply that to your auditing task, to extract the necessary information for your particular task. With the caveat that I mentioned on Tuesday, there's a whole industry segment of building this kind of tooling for cybersecurity purposes of system, workplace, organization-wide auditing and consuming of log and providing alerts and warnings and things like that. Anyone knows how to print in many ways, is to print the last 5 lines of access.log. You have cat, which prints the whole animal. If we want to just print the end of the animal, how do we do that? Tail. Hey, you got it, okay. And somewhere with the tail command, so usually, not all, but most commands, if you type in -H or -help, and there's also manual pages you can access, I don't know about in this system, it'll give you a hint as to some of the options for it. This is one of those things that it's written in kind of historical manual page style. Everything written in a help page or a man page is correct. It's useful. Sometimes it takes a little while to gain experience in how to process that information they're trying to provide for you. It's not super user-friendly. It's all there, so they're not hiding information from you, but in terms of how do I get exactly what I need so I don't have to spend 30 minutes looking at the help page. In this case, tail, I believe, prints all the files starting from the end. There's a way to specify I only want to print 5 of the last lines, and that should be one of these options here. -N, output the last n num lines instead of the last 10, or use -N plus num to output starting with line num. So, and oftentimes with these utilities, there's a single dash version of the command. There's a dash version of it that maybe is a little bit more expressive. You can intermix them usually. One is not right, the other is not wrong. -N looks like it would work, or -- lines equal would also work. So we'll do -N5, access.log. Success? Okay. Create an empty file. Anyone know how to do that? Touch. You guys already know all this stuff. Okay. Well, I think it'll get hard enough. Touch. You could also just, if you wanted to, echo blank and then output the results to a file, but we can just touch. And I doubt I can tab complete that. But how would it know the name of that file? Must be, right? Yeah. Yeah. Well, okay. So it's not a full. It's a toy shell. It shouldn't be able to tab complete that file because that file does not exist yet. But that's fine. There you go. We have touched that tab complete. I really doubt it. I don't think it's a real terminal. Command not found. Ed. Nah. Limited things. I don't think it's real. Okay, might be real. Some sort of JavaScript-based command environment. Interesting. Okay, we could try to break it. That's a separate skill. That's also kind of fun. No, but this is a useful utility for people. Let's not break the poor person's website. Okay, create a directory named temp files. What's the command to create a directory? Makedir, at least. I don't know. To what extent do you like spell out these commands? To what extent do you just say them? I don't really know. I've always called that makedir. Maybe it's not. Maybe it's mkdir. I don't know. Makedir temp /files. You could do that. That actually wouldn't work, right? We'd have to makedir temp and makedir temp files. There's also a way to specify somewhere with makedir that like, hey, don't worry about it. Even if the as it says, the working directory temp, the directory doesn't exist, create it anyway. -p, I forget what it says, permissive mode or something like that. Copy the file. What's the copy command called? Copy. Copy that file to the directory, temp files. You can specify the name of the file you want to overwrite. You can use the trailing directory symbol, but you also don't need to. Move. What's the move command? Move. Maybe we have more expertise in here than I assumed based on what I was seeing in lab. Move this to that directory. Done. Create a symbolic link. What's the symbolic link command? Okay. Do we even know what a symbolic link is? That's an important thing in the first place. The other term in other operating systems, you'd hear it referred to as just a shortcut. Okay? Meaning like, you know, in Windows, I don't want to mess around with my desktop right now. You have a directory somewhere and it's like 7 subdirectories deep, but you want pretty quick sort of GUI access to it. You create a shortcut to that. That's a kind of quick way to get to something that's a little bit more obscurely located in your machine. In Linux, we separate between the concepts of symbolic link and hard links in the file system. And so a symbolic link is exactly just a shortcut, exactly as I mentioned, for basically the same reason. I want to CD into a very complicated named directory and I don't want to have to remember what it is every time. So I call it my shortcut or something. There's also a hard links which actually directly redirect you to that location. And there's value of doing both. The symbolic links maybe are most common. We want to create a link command. The command's called link. I don't remember. Link. One of these has got to be a symbolic link. Look for the word symbolic somewhere. Link -s. Only issue with this link command is what order does it go in. With copy and with move, it's pretty obvious. So it's target link name. So link -s, you can think of it like link source. So we want to create a symbolic link name to take the command challenge, and it's going to let us tab complete because it's cheating. That points to that file, and that entirely tab completed as well. So created a symbolic link. That way we don't have to remember what directory that file's in. We can just access the symbolic link and we effectively are accessing that file. Symlink does not exist. Let's try that again. What did I do? ln-s, I did it backwards. I said target, source first. You're supposed to correct me on these things. And the name of the link that we are creating. Okay. Here's a dangerous command. To remove files, it is rm. If it was old DOS, it'd be del delete. But rm. Delete all the files in this challenge directory, including all subdirectories and their contents. rm-rf star would delete everything in the current directory, but it's going to miss like subdirectories. There's a lot of ways to do that. I think, is it star would also do that for you. Or you could do like, give me everything in this directory, and then everything in a dot directory, so that'd be dot star. it's not like our regular expressions, which meant like 0 or more matches of something. That just means anything that starts with a dot also give me that set of directories as well. There's probably a better way to do that, but that's good enough. Okay. There are files in this challenge with different file extensions. Remove all files with the .doc extension recursively in the working directory. We did that pretty quickly. rm remove dash recursive, that's R. You can do /-f separately, but you can do it all at once. Force, don't give up if someone thinks it's a bad idea. It's a very dangerous command, right? That's, hey, delete things and don't even warn me if something bad is about to happen. We've all experienced blowing away our whole file system once or twice in our life, and it's a learning opportunity, a growth opportunity. But you have to remove all files to the doc extension recursively in the current working directory. I don't think that's going to work. So I could do star.doc and .star star.doc. I don't know if that's going to work. Got 6 files, expected 4. Okay. Recursively, that's going to be a problem. So that's not going to go recursively down. If we want to make sure we can find all of our files recursively, there's a command called find. I should have been able to get it to work, but I can't think about it. Find everything with the name .doc is what that's saying, right? With asterisk or wildcard match .doc that found all the files. And I could probably, there's a delete flag for find. That feels like it's cheating. I didn't know that. There's a way to pipe it to an RM command. Okay, moving on. Now we're actually processing logs. There's a file named access.log in the current working directory. Print all lines in the file that contains the string get. What's the command that was on the slide? When we want to, someone already said it, I think, when we want to look for things in files, we want to grep things. Don't recall why it's called grep. I like it though. It's become a verb now. I need to grep that file. I need to look for things in that file. I don't actually know if I need quotes, but there's no harm. Let's put quotes around it and grep, looking for that string, in file access.log. You weren't expected to know that, other than that was the example that was on our initial slide about auditing here. A couple more. They're getting a little tricky. I'm getting limited in my own skill set here. Print all files in the current directory, 1 per line, not the path, just the file name, that contain the string 500. But we can't just do grep 500. That seems like that would work, but it's printing the file name as well, right? It's printing the name of the file and the matching string. So there must be a flag to grep that's going to print the file name only. Now, again, we talk a little bit about chicken and egg. So the question asked to print the file name only, and it's either an option in this command or it's not an option in this command. And in this case, you look at the help, it is an option in that command. Does one need to memorize that? -L, lowercase l? Probably not, right? I don't think it's important to have any of this necessarily memorized. But knowing that the command is called grep, and that's probably your starting point for searching in text through files, is probably sufficient. So grep -L 500 star should give us just the names of the files that are matching. Print the relative file paths, 1 path per line, for all file names that start with access.log in the current directory. The relative file paths. LS? Yeah, okay, I don't know. That was a weirdly phrased question. That one doesn't need anything complicated. I wonder if it was worded poorly. Print all matching lines without the file name or the file path, and all files under the current directory that start with access.log and that contain the string 500. So without the file name or the file path, so I'm sure that was there in the list of options. -L was files with matches, is there a way to say don't list the file? Does it say that there, or did you cheat and look it up? There it is, no file name. Nope, not accusing anyone of cheating. There it is, -h, you got it. Recursive, I saw it as well. grep -8rh 500 star, okay. Extract all, okay. See, we're glazing over a little bit. I don't know how many of these there are, and I don't think we can get through all of them, and then we're really not learning about auditing. Extract all IP addresses from files that start with access.log, printing one IP address per line. Files that start with access.log again. So let's do ls. So it's okay to kind of build these up piece by piece, right? Can I get every file? Well, that's weird. Find, let's do the other command, access.log. Okay, those are the two files we have to process. Now you can start to pipe these results to other utilities to say, hey, I want to see all the contents of those files. There's a dash. We can just pipe it to cat. That seemed to break. We can say, give me command line that's an input to cat. Okay, there's all the contents of all those files. So we've just built up a command. We've taken the results of the find command. We say, pipe it to a command called cat with the arguments as the result of that previous command. And now we need something that's going to print out just the IP address of that. There's actually like a dozen different ways to do it. I'm sure there's a very specific command line or utility to do exactly that. But the one that's a really good workhorse for this is called awk. Has anyone used awk before? Okay, we have half an awk user in the class. I would also describe myself as a half awk user. That is definitely someone's initials or a set of people's initials. That doesn't stand for anything. It is a little awkward to use, yuck, yuck, yuck. But we can see here that this can be thought of as kind of like a space delimited line, that there's a lot of contents here, and that's what that command is really good for. It's taking a text, taking a file, think of it like a CSV file, but it doesn't have to be separated by commas, separated by whatever you need it to be, and allows you to kind of access each of those entries independently via some environmental variables. So when you use the awk command, and I think by default it'll allow for spaces for the separation. This would be the first entry. There'd be a dash, second entry, third entry, fourth entry, etc. This would be a harder problem, a much harder problem if the lines were not starting with the IP address and if they had an inconsistent format to them. That's just a harder parsing challenge in the first place. But in this case, there had to have been a better way to do this, but in this case, because it's the first entry, we can just tell it, grab that content, print the very first entry of that line, and that should get us our IP address listings there. Okay, last one for now. You guys do more later. Count the number of files. Do we know a command that does counting for us? There's a lot of them. Sure. Absolutely. WC is a word count. It's technically what it is. Well, I don't even know what files are even in the directory. And again, I don't know how limited this is. Does it even let me like do it? It does. So word count counts words. There's sometimes some value in doing that. Where you tend to see it more commonly used is basically as like a line counting utility. So WC-L prints out the number of lines of a file. There's all sorts of reasons that'd be something you'd want to do. Print the number of files in the current working directory. So we take ls, which gives us, there was just one file there. Should be fine. ls, take the result of that. That's what that pipe operator does. Treat it as the input to a word count utility. That's certainly correct. Well, it's a good time to stop on this. Count the number of files in the current working directory. Print the number of files as a single integer. Total 4. But that is, something is wrong with regards to that. But if we do ls-l, it'll work. But I think their code itself Their code is wrong. So, okay, we found a broken, let's go back to that one. That one's wrong. Count the number of files in the current working directory. There is one file. Oh, that's what I did. Say it again. There's one that's got a dot hidden. That's very mean of them. So ls-a would be wrong. So we got this correct accidentally. It's the very best way of being correct. All right, let's move on from command line challenges. You're very welcome to do more of those yourself later on, see how far you can get. I think the solutions are all there, which kind of takes some of the fun out of it, but whatever, you can still challenge yourself with it. Let's go back to this topic of auditing, right? Part of it is really just kind of looking through logs, consuming logs, determining what has to happen. There's an equivalent Windows version of it. I won't even open it up, but there's Windows Event Viewer. And while it's not that kind of nice flat file structure, sort of the Linux way of doing things, there are also program-based hooks to be able to access effectively the same exact type of information associated with it. Windows' version is more centralized, more kind of sticking to a common theme, whereas Linux, it tends to be a bit more ad hoc. It's that each service, each application creates their own way of doing logging, and so you have to have your own way of parsing all the different logs here. But the trade-off is the nice text kind of format. It's human readable, whereas this is a convoluted GUI where it could be also easy to miss certain key events as they happen here. So that's auditing. That's all we really need to talk about. Remediation is the second part of it, right? Remedying something, fixing the problem. There's not going to be one size fits all solution for what it means to remediate or remedy a problem here, because it's not necessarily a solvable problem in a common sense here. That if you have an RC, remote code execution vulnerability for the open SSH server daemon that you're using, it was just disclosed today. Just as a thought exercise. What does it mean to remedy that particular vulnerability? What are your thoughts? Sure. Potentially. Now, again, the answer is always potentially for all these potential answers here, right? That could be a good solution. Hey, this big vulnerability is discovered. We're totally vulnerable to it. We like to use SSH, and we're going to go without it until this gets fixed by our OS distributor for us, or package distributor for us. If SSH is fundamental to your business model, that may not be a valid solution. What else could you do? Sure, I'm hearing lots of ideas. It's great. It depends, obviously. Certainly, once you recognize that you are vulnerable to a particular exploit that's in the wild, part of the remedial action is to increase your sort of surveillance and your auditing, your sort of real-time live auditing of what is happening, right? You could look at your network posture and say, well, I can't shut down SSH. It's too critical for us to be able to function as an organization, but perhaps I tighten the rules even further. And perhaps this one subsidiary that's in this location is not going to be able to access it, but these people over here are going to be able to access it. Or increase your logging at the current time. So hey, we know there's some potential vulnerability. We can perhaps shut down or at least detect if we're actually being actively exploited, and then maybe at that point we actually decide to shut it down. It's not going to be a one-size-fits-all solution. It really does depend on the nature of what we're doing. Because for the most part, and I talked about this before, when we look at vulnerabilities and we look at patches to certain vulnerabilities or exploits for vulnerabilities, those of us who are doing sort of the cybersecurity auditing or are just involved in kind of the defense side of things, we are not also going to be the developers. For your own product, perhaps, right? You have direct control over your own software products and how you need to push out rapid changes if there's something detected. But that's not going to be the case, right? That's going to be the case for one piece of software or a handful of pieces of software out of the thousands of softwares that you're using for all the things that you need to keep your organization going. So by and large, your organization is not going to be able to develop and push patches for the software that you find to be vulnerable or that others find to be vulnerable. You're going to be reliant on sort of the sysadmin. And so the sysadmin's perspective is very critical here. Meaning the person whose job is to maintain those machines. That is usually a different set of people. Of course, they should be working in concert than those who are doing the cybersecurity auditing, right? Depends. That's all very organizational, how companies want to structure things. Perhaps it falls under all the same exact IT umbrella. But in a large enough organization, that's going to be a separate set of people. Those who are kind of pushing patches, checking to see that computers are working as expected, and those who are determining whether there's some particular new risk to the computers that are running here. And so you who detects the issue will not be necessarily the person who actually applies the fix. So there's a little bit organizational challenges you may have to overcome. Now, I don't think you go to a company, it's not your job to necessarily fix the structure of how things are operating. If you're an external third-party consultant, it's probably sufficient to say, you've raised these concerns. It's up to the company to determine whether or not to fix them. But there's an interesting, I think, trade-off between sort of the sysadmin's perspective. In our department, we have wonderful sysadmins, and the security consultant's perspective here, right? Security consultant's perspective, you detect an RCE vulnerability in a service, and of course you don't panic, but this is what you're there for, to detect those things and hope that some change gets affected because of that, what you've detected. Sysadmin's perspective oftentimes is more about stability, uptime, not preventing the lawyers and the accountants and whatnot from using their Microsoft software to get their job done, not preventing sales from being able to access the Salesforce app and things like that, right? So there's a little bit of a conflict there, kind of a natural conflict there, because what will happen in practice, oftentimes, it's very easy to say, well, here's this vulnerability in OpenSSH, apply this patch, and you're done. And perhaps for something like SSH, that will generally be acceptable, will generally work. For more complicated web frameworks, other more complicated applications, it's not necessarily going to be as simple as saying, push out this patch. That patch, for a sufficiently large organization, sufficiently complicated piece of software, has to be separately tested. You need to know, or these people need to know, their job is all about, are the people who are doing the profitable work in the company able to get work done? Is engineering able to get their work done? Is accounting able to get their work done? And so forth. And so it's not as simple as saying, every time there's a patch, push out every single patch that is available, whether it's part of a standard cycle, whether it's part of a as soon as possible type of cycle. So there's a little bit of something you have to navigate beyond just saying, please patch all your systems immediately. And in practice, it's not always that simple, and depending on what type of software you are running in your systems to be able to patch everything immediately. So I already kind of mentioned that, right? You are not typically the developer or the capability to personally patch the software vulnerabilities as they are discovered. Maybe for one particular piece of software or one particular patch, but in the general case, that's not going to be true, that you are, as the person discovering the vulnerability or getting knowledge about the vulnerability, are not going to be the one who's actually going to be able to patch the vulnerability. And it's not your job generally, unless you're working for a very small organization, to also do the upgrading paths and the patching paths yourself. It's not as simple as saying, just hit apt-get, upgrade. The updates may not be available, may not be compatible, and that's something that you may not have visibility in, and it may then require significant testing before doing that deployment. Sometimes quick fixes can be applied before waiting for official patches. Other times, though, there's just inherent conflict there. So I want to talk a little bit more about versioning and OS patch management and what that means both in Windows and in Linux. Let's push that to next Tuesday. We don't need to jump into that right now. So next Tuesday, I know you'll all be back. Let's come back for this topic. We'll talk about semantic versioning, which is kind of a side topic there, and also in sort of the Linux, Windows, other worlds. What does that look like in practice? Some of that you may already be familiar with, so we may be able to go through it fairly quickly. There's a couple of interesting issues with regards to versioning and patching that I'll want us to talk about on Tuesday as well. Let's leave things here for today. Good luck on your lab.